this lesson 2.1 part B. You're going to simplify rational expressions. So just as a recap, rational expressions are when you have polynomials on the top and bottom of a fraction. So monomials are when you've got nothing separated by a plus or subtract sign. That's the difference. So if I've got something like 5x cubed y to the 7 all over 15 x y squared. If I have something like this, we would simplify according to our exponents, okay, and that's our exponent clause. So we would math frat what we put in here. These are our coefficients. So the coefficients, you actually divide them. So in your calculator, you can take 5 divided by 15 and then math frat. Hopefully you know they all divide by 5, so you get 1 over 3. Okay? So that's going to give us 1 over 3, and now we've got to get rid of our, reduce our variables. When we reduce the variables, put in those little hiding ones. They hide everywhere. Don't forget they're there. So I've got a 3 subtracting 1. How many x's do I have left? X squared. Okay? I have a 7 subtracting 2 for my y's. That's going to give me y exponent 5. So you could have that hidden 1 in front there. You could also see this as 1/3 as a fraction, x squared y 5. So they could show it as a fraction beside the variables, or they could just show it as the variables on top versus what's on the bottom. Okay? All right. Now we're going to talk about how do you simplify them? What are the rules? What if they're not monomials? So, when is it in simplest form? You have part of this on the bottom of your page 10, and the rest is on the top of page 11. So, when are your rationals in simplest form? When they only have a common factor of a positive 1. If that's the only thing you can reduce out is a positive 1, then you know you're simplified. So, right here, they have no common factors other than the positive 1. That's how we do know that they are simplified. Now, in order to figure it out, you have to factor the expression fully first. If we don't factor it, we won't know what we're able to reduce. Now, if it's a monomial, we like those because there's no factoring. There's nothing to factor, it's just reducing. So, we've got a couple different situations here. We're going to take a look at all of them. So it says, always state the non-permissible values of the variables as restrictions before you simplify after it's factored, though. So you factor, then you state non-permissibles. So what's a non-permissible again? You've been away for a few days, so what's non-permissible?
Something x.
Okay, something x can't equal where? Top, bottom, middle, side, on the bottom of your rational expression, so in the denominator. So we don't want our denominators to have a bottom answer of 0. That's what we're avoiding. So what we do is we try to find out what would make that become a 0. And then that's what we say x is not able to be. So in this case over here, I've got an x on the bottom. So since x is on the bottom, what can't x be? 0. So x cannot equal 0 in this case. Even though when I reduce this one, between the 7 and the 3, the 7 divided by 3 evenly. No, we're going to get a repeating decimal. So because we can't divide them easily, what we're going to do is we're just going to leave them as a fraction. So this is going to stay 7 over 3. Now with our variables, we're going to take x6 and subtract x2, and we're going to get x exponent 4. And that's going to go on top of your 7. Okay? Now, if you look at our answers, do I have an x variable in the denominator? No. So, that is why we need to state our non-permissibles first from the factored form. Or if they're monomials, you just do it from the very first version before you reduce. Okay? So this guy started with an x on the bottom, but in our answer in the end, he didn't have an x at the bottom anymore. That's okay. But we can't say he has no restrictions because he started with 1 on there. So we can't say he's XER, his x can't be 0. Okay?
What that would define what's on x on the bottom.
Oh, yes, we're going to talk about that when we get there, yes. Absolutely. So, what's that? Oh, hush. So, example 1, we've got nothing left on the bottom, but we have to state its restriction. This guy, we're going to have the same idea. So we have an x and a y on the bottom. They're stuck together, so that means we have to find their monomials. What can x and y not equal? If one of them equaled 0, the whole bottom is equal to 0, because 0 multiplied by anything is 0. So that means here, x can't be 0 and y can't be 0, because they're both on the bottom. And if one of them is, it makes the whole bottom 0. So we put our restriction first. Now we literally divide if we can. So we divide the coefficients. Does 15 divide by negative 5 evenly? Yes, negative 3 times. Okay? When we subtract our x's, how many do we have left over? 2, x squared. Subtract our y's, how many do we have left over? 1. Good. So y exponent 1, you don't have to show the 1 on here. Okay? We get our final answer. Now, that answer doesn't even have a denominator. The hidden denominator would be over 1. So that's why we have to state our restrictions first. Because both of our first 2 questions, we reduced it so there was no variables on the bottom. And that will happen sometimes. All right, let's take a look at number 3. Number 3 is written left to right. So literally what we've got to do is we've got to put it in fraction form. Put the 12 under, x squared, y squared underneath. Okay? And then now we can divide up and down. So 12 won't divide by 16. So you're going to have to math bracket. So you're going to go 12, divide, 16, math, enter, enter. That's going to give you 4 over, good. So 4 over 3. Now we're going to subtract our x's and y's. So there's a little trick I want to show you. Whenever you're subtracting and you've got a denominator and a numerator, top and bottom of a fraction, look at where the largest exponent is, because that's where the answer of that variable will go. So for example, if you look at my x's, I have a 5 and a 2. Who's bigger? The 5. So my answer is going to end up on top where that 5 is. And it does. So it's going to be x exponent 3, because I have to subtract my exponents. Now, whenever we solve any subtracting exponents like this, all of the answers always go on top. Okay? And I'll show you the quick trick in a sec. So if I go y1, subtract 2, I'm going to get negative 1. So I would have y to the negative 1 on top. Because when we first solve everything, they all go on the top. But this is this quick trick I wanted to mention. If you already understand that you're going to get a difference of 1, and that the guy on the bottom is bigger than the guy on the top, this guy's going to have to go down to the bottom in order to lose that negative. Okay? Because remember, whenever you flip, whenever you flip them, they are always going to change their exponents. Whether they're positive or negative, they'll go to the opposite. So if I flip the y downstairs, he becomes y positive 1. Okay? So, that's what our final answer is going to look like. We're going to have 4x cubed over 3y. That would be our final answer. So it looks like we have no x's on the bottom, but we started with x's on the bottom, which means we have to do our restrictions, which we forgot.
So whichever is the biggest exponent, that's where the thing is going to go?
Yeah, that's where he's going to go. So this x to the negative 1 goes to the bottom here. He's a y to the 1. Y is bigger on the bottom, so that's where his answer went. X is bigger on top, that's where his answer went. Okay, so just get used to that. Yes, yeah. So we still need to say x can equal 0 and y can't equal 0. How come I still have to mention that x can't equal 0? We only ended up with a y on the bottom. Because it started on the bottom. You always take it from the monomial stage when it starts on the bottom. Okay, those are monomials. If it's in a divide situation, that's monomial. Okay, so if it's in a monomial situation, you got to check and see where it started. Where did the variable start, bottom or top?
So since, like, before switching the y to the bottom, why wouldn't you just take the 4 and the 3 and then also flip it?
Because this guy has a positive 3, this guy's got a positive 1. You only put the guys with negatives. Okay? Good question. All right, let's take a look at number 4 and 5 here. So number 4, we're dividing by 5x. That means both terms are going to divide by 5x. So we do have a variable on the bottom, so what can x not be here? 0. So we say x cannot equal 0. if x equaled 5, I would still be okay, because 5 times 5 gives me a digit of 25. Okay? There's nothing separating 5 and the x. That's what we're indicating if you're thinking that. Okay, so now we're going to simplify. 5 divided by 5, 1 time, you have x to the 1 left over. Negative 10 divided by 5 minus 2 times, the x will cancel on this side. So your answer is going to be x minus 2. You don't even have a denominator anymore. Okay? Your denominator is that over 1 business, where we don't have to show that all the time. So x minus 2 is our final answer for this question. Okay? Look at number 5. Look at the way it starts. Do we have a variable on the bottom? No. So that means there's no restrictions. How do we say no restrictions? XER. We have a variable A, so we're going to say AER. Okay? AER. There's no restrictions. And now we're literally going to divide. Now, when we divide them, they're going to give us decimals, so we have to math bracket. So, 18 divided by 12 is going to give you 3 over 2. Okay, I'm just going to erase some of this stuff so it's out of your way. So you can see what question we're working on here. Okay. So this guy is going to give us 3 over 2a to the 4. All right. What is 6 divided by 12? What's that going to give us? 1 over 2. So 0.5 or 1 over 2. So plus 1a3 over 2. Do I have to include that 1 in front of the a3? No, you don't. Okay, on the back, negative 12 divided by 12, a hidden 1 time. So minus 1a squared. Okay, that's how you would simplify that one. Now, because 3 over 2 and 1 over 2 are exact decimals, you can use 1.5 and 0.5.
Why don't we like triangle the top of it and take our GCF?
Why don't you diamond it?
Yeah.
Because all we're doing is reducing. We're reducing it with the bottom. And whenever we have a denominator, you always have to reduce first if you can. Okay? All right, next question. All right, number 6. So this is what you got on the bottom of your page 11, sort of mid-page 11 here. So, number 6 says, write a rational in simplest form. Now, these are monomials. This is a binomial on top of a mono, and then we got a bi on top of a trinomial. Now, these ones, where we've got a 2 in front of x squared, any number in front of x squared, we're going to factor for you. So, I'm going to give you the factoring for that one. So that one is going to be 2x minus 3 and x minus 4. Okay, so there's the factoring for the bottom. We're going to work on 15 first. Or sorry, the 15 and 20 here. All right. So 15 and 20, we're going to math frac. They're both going to divide by 5. So we should get 3 over 4. Now we're going to reduce our x's and y's. So x, we're going to have 1 left over on top. Y's will reduce completely. And z, I'm going to have 2 of them left on top. Okay? And again, what are our non-permissibles here? Right, all 3 of them. X can't equal 0, y can't equal 0, and z can't equal 0. Okay? All of them cannot equal 0. All right, let's look at the next one. This guy right here. Again, you're going to have fractions because or decimals. 3 divides by 2 1.5 times. So you're going to have 3 over 2x or 1.5x. 8 divides by 2, negative 4 times. Your x will disappear on the end there. What can x not be in that case? We start with an x in the bottom. X can't be what? 0, right? All right. When we have brackets like this, again, we're trying to see what makes each bracket equal to 0. So what would make this bracket equal to 0 with the 4? Right, so this guy is positive 4, makes that guy equal to 0. When we've got them with a number in front of x, all it does is change the answer to a fraction. So you would take the number out of brackets, the opposite sign, same as we did here. So 4 came out as a positive 4 because he's negative in brackets. This guy here is a negative 3 in brackets. He's coming out as a positive 3. But because there's a number in front of x, that's going to come down and create a fraction. It's actually 3 over 2. Okay? And that's how it'll always work. Now, the long way to do it would be this. Make each bracket equal to 0. That's what we're doing. So we would go 2x minus 3 equals 0. Take the 3 over, plus 3 to both sides. So we're going to get 2x equals 3, divide out the 2. So we just did the quick trick. Okay? So the long way is to do it is this way. And again, all you're doing is making each bracket equal to 0. If you make it equal to 0 and then solve for x, you're going to get what we did doing the quick trick. Okay? So the biggest thing you have to remember is that the number in brackets at the end, take the opposite sign. That's how it comes out. So negative 4 comes out positive 4. Negative 3 comes out positive 3. Check if there's something in front of x. If there is, scoot it below. And then that's all there is to it. Okay? So this is what x cannot be because that's our bottom. So we're saying x cannot be those guys. It can't be this and it can't be that. Okay? So it can't be 3 over 2 and it can't be positive 4. If it is, then we have a problem because that makes our bottom 0. So now we got to factor our tops. We still have to simplify. So if we factor the top, we're going to get the square root. We're going to get 4 plus x and 4 minus x in brackets. Now, do we have anything on the bottom that looks identical, that is written identical? We have something that's backwards, but something that's not identical. So, we can match it with this guy right here, x minus 4. But this guy up here is written backwards. He's got 4 and the x in the wrong spots. So in order to do that, when we first factor those, what you try to do is look and see if the x is first or not. And then on the bottom here we have x first, the digit last. So we want x first, digit last. That means we have to reverse the order of those two terms. Whenever we reverse the order, you need to reverse the order. When you reverse the order, you've got to divide out a negative 1. Okay? So it's going to look like this. Negative 1, negative 1, and then you're going to have x squared minus 16. All that taking out a negative 1 does is it reverses the way they're sitting. And that's going to reverse the way they sit in the brackets then. So now, this guy's on top. We have to factor that guy. So now it's going to become negative 1 bracket x plus 4, x minus 4. I'm just going to erase some of this stuff so you guys can see what's going on. Okay, so we know what our bottoms have to be. Okay, so what we're going to end up with is this. Negative 1 bracket x plus 4, x minus 4. That's this guy right here. We're putting it all on top of our denominator. 2x minus 3 and x minus 4. Whenever there's something on the top and the bottom that's identical, you can remove them. Okay? So, the x minus 4 is identical, so I'm going to remove those. So now your final answer to this question would be this with the non-permissibles. Okay? So you have to be careful about those ones that have a negative there. You've got to take that negative out so you can reverse the order of those two. And that's super important for those. All right, we're going to take a look at the bottom right on number 7 here, because we're in the same situation. Okay, bottom right of number 7. So, did we get that written down? Yeah? Okay. So the bottom right here, this guy right here, if I factor the top, they have to give you those ones factored. So that guy, do I have it factored? is going to be 2x minus 1 and x minus 3. That's going to be your top. Do you notice, is the digit first or is the variable x first? The variable x is first, so because the variable x is first, we need to reverse the bottom so the variable x is first. So we're going to divide a negative 1 out of the bottom so that I get x squared minus 9. Now we can do the perfect squares, different squares factoring on him. So we would square root, and open 2 brackets. So on the top again, 2x minus 1, x minus 3. That's our top again, our numerator. The denominator is going to have a negative 1, x plus 3, x minus 3. And now that we've got our bottom factored, now we need to do our non-permissibles before we reduce everything. Okay, so we factor the top. They'll give you the ones, like I said, mostly with 2 in front. They'll give you most of those back. Now, the only thing we had to do was reverse the bottom. Okay, we reverse the bottom, we put the x and the 9, they swapped places. Okay, so they swapped places, now we can square root them, and now we've got our square rooted brackets. Okay, at this point, this is where we do our non-permissibles. Everything's factored, non-permissible time. So we look at both of our brackets, where the x's are. What would make our brackets equal to 0? Plus and minus 3, both of them, right? This guy over here makes positive 3. This one makes negative 3. So we'd say our non-permissible values, x cannot be plus and minus 3. Okay? All right. Once we have the non-permissibles, now we can simplify and cross out all the common factors. So, common factors of x minus 3 disappear. In our final answer, that negative is going to float to the top. So we're going to have a final answer of negative 2x minus 1 all over x plus 3. In any situation for any fraction, your final answer negatives will always float to the top. It's just a general rule.
How is that? Just take the negative 1 out. Like,
Okay, I'll show you. Okay. Let's take a look at the first one here. We've got a negative and a positive. What are you going to do to the 25 and 35? Nope, it's a monomial. So you're going to math frac. So you're going to put it in your calculator. You're going to go negative 25 divide by 35. Okay? Negative 25 divided by 35. And then you're going to divide it out, math frac. Math, enter, enter. Okay? They're both going to divide by 5. So you should get negative 5 over 7. Okay, did you guys get negative 5 over 7? Beautiful. All right. Which letters do I have on the bottom? A and B. So A and B need to have restrictions. But does C have a restriction? No, because he's on top. So we say CER. C has no restrictions. Okay? A and B, what can they be if they're stuck together? 0. Good. All right, now we start reducing the variables. So, A3 subtracts A1. How many A's left over? 2. Where is the bigger B? On the bottom. So now we just subtract the digits. 5 subtract 2 is 3. So it's a B3 on the bottom. Okay, so you just subtract the digits, but wherever the bigger number is, that's where the answer goes. 5's bigger, so his answer on the bottom. C, he's all by himself. He just stays by himself up top. Okay? The next question. We can take and do the non-permissible right away. So what can x now be on the bottom? 0. So x cannot be 0. Perfect. All right, we're dividing out of 3x. So 6 divides by 3 2 times. subtract your x's. x2 subtracts x1 to give you an x1. 12 divides by 3, positive 4 times, and your x will completely disappear. Okay? That one has no denominator left, which is okay. All right, the next one has a difference of squares on top. So what are you going to do at the top? Square root, square root. So we're going to get two brackets, x plus 7, x minus 7. All on top of. We do the diamond on that guy, we're going to get x plus 2 and x minus 7. So now, we've done step 1, we've factored it. Step 2 is non-permissibles. So now we look at our bottom. What can x not be for the first bracket? -2. What about the second one? 7. So x cannot be -2 and 7. My board is delayed today. I don't know why it's being so delayed. Now we can cross out common factors. Anything common on top and bottom now we can wipe out. So we're going to get rid of our x minus 7s. And our final answer is going to be x plus 7 over x plus 2. As soon as it shows up, there it is. Nope, there's no negative. We didn't have to turn anything around. Nope. That's only if you have to switch something places. All right, a couple more examples here. Okay, so you're going to notice on mine on the next page, so mine's going to look different than yours. You guys have a different set of questions there, and it says A, B, C, D, right? That A, B, C, D on page 12, those are the same questions on the page before. So they were a duplicate, so you just cross them off, but we're going to write a couple other questions in their place, so don't make lots of too terrible of a mess. So we're putting other questions up there. All right, because in everything we do, we always have to correct and identify errors. And there's always at least one of them on the diploma. Okay. What is our first step? Starts with the letter F. Factor. All right. Is this guy factored? No, sir. So we're going to factor. What can I take out of the top? A 2 and what else? And an M. Because they both have M. So I can divide out a 2M to the top. That's going to leave me a 3M, subtract 4. Okay, now we're going to do the bottom. What can you take out of the bottom? M squared. Good. M to the 2. What does that leave me? 3M, subtract 4. Good. So, that was step 1, factor. What's step 2? Non-permissible values. So we have to look at our bottom. We have a variable sitting beside a bracket. What does that always equal to? 0. So, the first one right there, m can't equal 0. Now we deal with the brackets. In the brackets, the opposite sign of the guy on the end, so positive 4, and we look in front of x. It's got a 3. So this one's going to give us m at b positive 4 over 3. Now you're going to have a fraction for that one because there's a letter or a digit in front of the variable m. Okay? So now we've done our non-permissibles. The last step is to reduce everything. So I can reduce my common bracket. There's my common factor. And I can also reduce what? Your m's. I've got m1 on top and m2 on the bottom. I can reduce those. I can take an m out of both. So my final answer for that guy is going to be 2 over m1. Okay, 2 over m1 will be our final answer for that guy. Pardon? Okay, because what we did was we had one here, getting rid of one of them here. Okay, so we're subtracting this guy out, and we're getting rid of 1. Okay? So that's how we get that for an answer. All right, let's take a look at B real quick. And then we're going to identify an error, and we are done. Okay. Can I erase my green here? Yep. Okay. All right, now we're doing blue for B. Okay, we're doing B. What can I divide out of the first one? 3a squared. You always take out the least amount of variables if they're present in all. So 3a squared. 3a squared divided by 3a cubed is going to give you an a left over. We're factoring top, we factor bottom. So you factor them separately. So now 3 divides by 3, negative 1 times. Okay, there's my top. What can I take out of my bottom? That's 12. So if I take a 12 out, I'm going to get a negative a plus 1. Is that what I want? Do I want a negative a?
No, you measure out the negative 12.
Right. We need to divide out a negative 12 instead of a positive 12. This is where we do that negative switcheroo thing. So if I take out a negative 12, what that does is it makes the numbers in the brackets switch spots in terms of their positive and negative. Now a is positive, now 1 is negative. Now they match what's sitting on top. So we're fully factored. That's first step. Step 2 is non-permissibles, NPVs. So, NPVs. What is a non-permissible? Is there any variables to be beside the 12? Nope, so we don't worry about him. What about the guy in the brackets? What makes him 0? 1. So non-permissible, x cannot equal 1. Okay? Now we're going to reduce common factors. So we're reducing common factors. I'm going to take off my a minus 1. And I'm going to math frac my 3 and negative 12. And your final answer, that negative will float to the top. So we're going to get negative 1a squared over 4. Okay. All right, I'm not going to make you guys write these ones down. We're just going to do them together. So these are identify error questions. If you'd like to write it down, you're more than welcome to write it down in that spot. So all you would draw is just literally this part right here. So this is what they started with. 3x subtract 12. Okay, do you want me to write it bigger? Yeah? Okay. 3x subtract 12. X squared plus x minus 20. Okay, that's what the first line says. So first of all, did they GCF the top right? Did they take the 3 out correctly? Yep, they divided this guy by 3 and this guy by 3. The top's correct. The bottom, if I diamond at negative 20, I'm going to get positive 4, negative 5. So I have positive 4, negative 4, positive 5. My bad. Next, we look at our common factors. I can reduce these guys. But this is our factored phase. Once we're factored, what do? Non-permissibles. So what's the non-permissibles here? Negative 5, positive 4. What is their non-permissible? Negative 5. What did they forget? Positive 4. So the error, everything they did was correct. The only thing they forgot was the second non-permissible. Okay, so they forgot. They had negative 5 as a non-permissible. It's actually negative 5 and positive 4 are the non-permissibles. Okay? All right. The next one just says that there's a student that claims these two are identical. Are they equivalent? Would you say that this 12x squared over 15x is identical to what's written beside it?
Yes.
It is. The reason it is because what's written beside it is identical on the top and the bottom, which means it could be reduced. If you can reduce it, remember, equivalency will always happen when you can reduce them to the same simplest form. If you put in a number and stored it for x, that means both should equal the same. So this guy here, if I reduce those, this is identical to that. So yes, they are identical in their reduced form. Okay? This concludes simplifying rational expression.